I'm really excited about a project that my students just did in my AP Physics C class using artificial intelligence to supercharge their learning about a physics topic that we didn't study during the year. So this was after the exam. I've done this every year and the results were so great that I wanted to get this down on video. Just a little background. The students were encouraged to use artificial intelligence to go deep in and learn. Now, some students did not, and those students that did not had a significantly worse quality of presentation. Now, any high school teacher that's had students create presentations knows how the results come out. You get a very pro forma set of bullet points. Students that present them tend to read off the slides. And that's what I experienced. The students that used the artificial intelligence the least tended to have uninspired presentations where they read off the slides. And this example that I've got here, the evolution of batteries, it's really not fair because they weren't doing a presentation per se. This was just sort of to have to the side so they could use this to refer to. But of course, what did they do? They did basically a Wikipedia search, they watched YouTube, and they had a very, again, uninspiring, not too interesting, very limited scope presentation. And I think part of that is because they didn't fully understand any of these topics. So it seemed kind of silly to go on beyond what they had because they weren't understanding what they had. And when I asked questions, you could tell they had some understanding, but it wasn't a deep understanding. And it really was not a very dynamic interaction that I had with them. So the goal that I had, the way I set this up is I said, you'll independently explore a physics topic of your choosing with the help of an AI research assistant, And in our case, it was school AI. The final assessment will be a conversation with your teacher, not a test or a presentation, although you can create a presentation if it helps. And what I found is the students who went the traditional route, created a presentation, they had written notes and they wanted to read off their notes and they showed no insights outside of their notes. Whereas the AI students wanted to talk off their heads. They wanted to talk off the top of their heads. They wanted to go to the whiteboard and they wanted to write diagrams and they wanted to interact with what they were talking about. And they were outstanding at answering questions. Importantly, it requires an authentic interaction to really get a sense of how they learned, okay? Having them do a PowerPoint presentation, even if they used AI to do their learning, is not gonna give the results that you want, okay? Having them interact with the teacher so you can actually probe a little bit and they can show what they've learned, they can elaborate. That's where the demonstration of the learning takes place. And I'll talk about the instructions that I gave school AI. They were very, very useful. But then at the end, they're supposed to explain their ideas in their own words, make sense of equations conceptually. I didn't really want it to be a big derivation where it's just one big math experiment. And then think about assumptions and limits to the physics understandings that they got. And they were concerned about how are they going to be assessed on this. And I said, your last request should be act as my teacher and interview me to ensure that I understand it. And I think that was a really, really useful prompt. So here are the instructions that I had to school AI. I put a lot in there. And basically I gave it guidance on, I said, act as a university physics professor. I wanted to have that expertise. Select a topic. I gave guidelines for selecting the topic. I gave criteria, refinement process, how to offer directions, but not really create a fully defined project for them, how to do the background research, how to engage the students, how to address confusion, and then how to foster inquiry, etc. So what this did was this allowed the student to interact with AI, but not have it just do all the work for them. And then at the very end, at the final goal on this whole thing was preparing for the oral interview. They can be asked about assumptions, approximations, physical interpretations of equations. So in other words, I gave it instructions, how should it act like me when you're having it practice for the final presentation. The next few slides are extremely text intensive, so I'm going to have my image disappear for a bit while I talk over it. This is an incredible amount of text that I want to show streaming by, because what it is everything that they had interacting with AI. And there's more research they did. In some questions in here, they said, give me some sources that I can study some other things. But I want to drill down on a few things. Okay? And you absolutely feel free to pause this and read what's going on. I'm going to try to go pretty fast. First thing, they come up, they ask for an idea. It helps them, it leads them. It doesn't select a topic for them. It interacts with them until they can choose something. They get down here, they say, can you elaborate on the level of physics and math researching this will require? So they were able to say, hey, is this something we're capable of? So it helped determine the suitability. Again, something that a student just kind of picking a topic out of a book would not be able to do. In here, they come up there and they say, can you help us come up with a plan for a solid foundation on this topic? And it helps develop the plan iteratively by interacting with the student. So, if you're worried about AI doing all the work, it really doesn't work that way. Here they say, can you one more time explain the general idea? In other words, they got into it and they were a little confused. This is after a lot, because if you look in this, the red is the students, the black is the AI, and the green dots, that's all sorts of stuff that I've deleted from the file because I didn't want to have to page through it, really. So it explained a lot of stuff, and they said, I'm not really 100% sure. If you're doing this on Wikipedia or YouTube, you can re-watch it or reread it, but you can't ask Wikipedia, what do you mean by this? So this is fantastic for them to really get a solid understanding of what's happening. This is a standard type of prompt that people use. Explain this to me like I'm a 10-year-old. So in other words, pick the level of comprehension. But they did that, and then they said, well, wait a minute, keep it scientific. I don't want an analogy. I just want simplified terms. So getting the AI, getting the LLM to give the information in the form at the level that they want, hugely important for them digesting it. This is one of the happiest moments of my teaching career. They took a quote, and they said, does this connect to Gauss's law in any way? Gauss's law is something we studied in class, so they're trying to connect this to their prior learning. They're trying to connect it to what they learned in AP Physics C. And same down here. How can polarized cells be compared to electrodynamics? They've got a scaffold, AP Physics C. They're trying to drape this new knowledge on top of that. And then Nernst equation, which is something they found from their readings, from the citations that they were given. They asked a question about that. Is it relevant? But this is another fantastic thing. From the guidance, the initial introductory prompt that I gave School AI, it was able to determine for your conversation with your teacher, you don't need to memorize the formula. That's something that I'd put in there. Just knowing this fact is a strong physics-savvy takeaway. So it saved them a whole lot of time and worry. And honestly, it made their presentation a whole lot better than me looking at this equation and having them try to stumble through that. These 5 things, I'm just going to do highlights. The top one, they're confused. They were able to reach back and clarify. The second one, I had deleted a lot of their stuff. They had a few paragraphs that they typed in and got feedback from the LLM. It says, this is a fantastic breakdown. Here are a few tweaks, and so forth. Then you get down to the very last part. They're closing in on the end of their project, and they say, my physics teacher is going to interview us. Can you test me? Sure. And it came up with, I think it was about 12 questions, really in-depth, and clarified their where they were right and wrong, and got them just a little more on target. And at the very end, it said, you guys are ready. Go crush this interview. And I love that, because students really need a little bit of confidence going into a presentation. They want to know, have we done what we can do? Have we accomplished the task that we were supposed to accomplish, or are we going to go embarrass ourselves? And this said, no, you're ready. Go crush the interview. And they did. So the results. We have the least AI groups and the most AI groups. Least AI groups, again, YouTube, Wikipedia, whatever, texts. they tended to read their project. They tended to read all the information. The most of the AI heavy students spoke off the top of their heads, showing that they had actually internalized the knowledge. The least AI had significantly less understanding on questioning. The most AI had deep understanding. They were able to answer questions about really side concepts, applications and so forth that they maybe didn't even study. Their understanding allowed them to extend that knowledge to other areas. The least AI, a standard high school PowerPoint. The most AI, they really wanted to interact. Some of them did have a PowerPoint. Some of them, most of them had just sort of an outline so they could keep to the story, but they wanted to go up to the whiteboard, draw diagrams, draw pictures, schematics, equations. They wanted to show the flow of understanding. They wanted me to understand how it worked. Least AI, terrible response to questions, really, really bad. Most AI, excellent elaboration. They really embraced this and felt confident and really had a positive outcome. 3 years I've been doing this, and AI, of course, has gotten much better. But the projects using a lot of AI have been significantly better than the projects not using AI. And that's true also of compared to all the projects before those 3 years when we didn't have AI. You could use this for science fair. You could use this for classroom projects. You could use this for end of the year projects. I honestly don't know what age group this would work over. My students are juniors and seniors. They actually, again, the ones with AI behaved like college students. The ones that didn't behaved like high school students. The recommendations I would have from doing this is, first of all, to carefully set up the introductory prompts in the LLM. So we had school AI. You can set up, I had that whole page that was it set up the environment. So any student entering that activity had the AAI was behaving a certain way. Okay, and that found that extremely useful. So it didn't give them answers. It didn't do all the work for them. It interacted with them in a certain way, and it assumed a certain amount of knowledge. You could do this with any AI, by the way. ChatGPT, if you only had ChatGPT and you didn't have the ability to monitor what they were doing, you could just set up an intro prompt, send it out to the class, and say, paste this up in the first prompt on your interaction with your AI. I would definitely have deadlines for topic selection, because that's a good indication. Are they using it appropriately, or are they just coming up with their own idea? You want to make sure that they are engaging with it, that there's a give and take. And I would strongly encourage you to have them show you, how did you come up with your topic selection? Show the chat that was involved in that. Rubric, I didn't have a rubric. My students were, of course, a little upset about that, but I said, look, just trust me not to be a jerk. I'm not gonna embarrass anybody. I'm not looking to, give D's. We're at the end of the year here. But if you were to set up a rubric, I would say I would set something up for being able to answer questions about alternate applications, extensions, things like that, or being able to not looking at text while they're giving their presentation. Just things like that might be really useful because they're a little more indicative of authentic learning. And make clear that the final product is interactive. In other words, if they go up thinking, it's just going to be like any other presentation I have in school, I have PowerPoint, maybe I have my notes, and I'm just kind of reading my notes, and I'm looking at my notes the whole time. If they think it's that passive, I'm giving information to the teacher, then they're not going to force themselves to really internalize the understandings. So good luck. It's worked out fantastic for me. I can't recommend it highly enough. And if you're local, if you're in Arlington County, contact me. I'd be glad to help you set something up.